Hey geometry students, it's me again. So how's it going? Hopefully you're not getting too stir crazy. I know I am. Makes it worse that I got these crutches behind me and just kind of tired of gimping around. So sorry for the long shadows here. It's in the evening, so gonna get going. All right. Tomorrow, Tuesday, gonna set up a Zoom meeting, so let's be there. We're just gonna answer questions, homework, stuff like that, and where we're going. So I look forward to just chatting with you and going through some parameters. But right now, let's work on this stuff. I'm gonna go through the guided practices and then a few more. So let's boogie. All right. So similar figures. You remember this symbol here? You know that's defined as similar using this triangle ABC is similar to triangle DEF, because you know those are the letters in the alphabet and the common ones we use. Remember, in order for something to be similar, all parts need to be similar. If we had parallelogram is similar to this parallelogram, then all parts. Now we get shortcuts with triangles. We could use, if you remember, angle, side angle side similarity. So if we could find two angles that are similar, then we know that the two triangles are indeed similar triangles. Okay. If they're similar, then their ratios are similar. We can set up a proportion and solve for a missing part. Okay. We can get a scale factor and say, hey, if we have a scale factor of 2, this one's twice as big as the other, then we can multiply by 2 to get the corresponding value. All right. So let's dive right into this. On page 737, you've got your formulas that you're going to be working with. So let me write those down real quick. All right, I went with the book here, and you can see my scribble, and I was like, yeah, no, I don't like that. So really what it comes down to is if we have the ratio of the perimeters, we can find the ratio of the perimeters. A represents side length if we have any side length of figure A, and then, well, corresponding side length of figure A and corresponding side length of figure B. So let me show that if I had this triangle, and then I had a bigger one here. Okay, and this is A, and this is B. Okay. But if I knew the perimeter, and I knew the perimeter of this one, I could I could find the ratios of the perimeters by just using one side length, and it works out the same. And the ratios of the area is one side length squared divided by one side length squared. Okay, what does this look like? Let's take a look at the guided practice here. All right, number 1, I'm going to go ahead and, okay, boom. Guided practice number 1. You don't need sketches, but I like to draw sketches. So triangle ABC has a perimeter of 16 feet, and it has an area of 64 feet squared. Triangle DEF has a perimeter of 12 feet, and they ask us, you know, what's the area of this triangle? Well, I don't have height, I don't have length. How in the world am I going to find the area of this little triangle when I only have, all I know that these two triangles are similar? Okay, well, we could set up a proportion and solve this. Okay, so I'm looking at my notes here. So I've got, were we provided with any other information? No. All right, but if I were to set up the proportions with their perimeters, okay, so I have 16 over 12. So this is both perimeters. All right. Now set that up as 16 over 12. I can simplify that down to 4 over 3. Okay. Now that is the ratio I can simplify, and that's going to be the ratio of their side lengths. Okay. Earlier, if I had the ratio of the perimeters, okay, I can simplify that down. That's the ratio of the side lengths. All right. That doesn't mean this side length's 4. It just means the ratio of the comparison between this side length to that side length. All right. So based off this information, now I can find the missing area. And I'm going to use this and set up a proportion. Okay? And so I can say, hey, the area of this one, all right, over the area of this one. So 64 over x. I'm just setting up a proportion. So it's this triangle divided by this triangle. So I'm going to set that up. So in the bottom here has to be this. But these are squared terms. Both of these are squared terms. And so actually, this is actually squared. This is area, but so I have to take these and correspond them to. If we look up here, the ratio of the areas is A squared over B squared. All right. So this is A, this is B. So this is going to be 4 over 3, and both of those are going to be squared. Okay. This is how these up here help me. Okay. So again, going back to this, that was provided with both perimeters. I set it up and reduced my fraction. All right. Then I was provided the area of one, but I don't have the area of the second. All right. Now this is just simple cross multiplication. Okay. So now I have 16 equals 16x, excuse me, equals 9 multiplied by 64. All right. And then x equals, and I have that worked out here, is 36 feet squared, because area is a squared unit. I'll double check my work here. 9 times 64 divided by 16 is indeed 36. Okay, so 36 feet squared. Again, if it's area and units are provided, please make sure you have squared units. Okay, so let me work. I'm going to go ahead and set up guided practice number 2. Okay, and 3 as well. So bear with me. Okay, so you've taken a look at guided practice number 2. It says the areas, the ratios of the areas are 20 to 36. Okay, and we're asking for what is the ratio of the side lengths. So essentially, using variables here, this is a squared over b squared. Remember, with this dot dot, we can represent it with a division like this, or we can use the word 2, but I'm going to go ahead and represent as division. So if a squared or b squared is this, then I know that the ratio of the side lengths is a over b. Again, using algebra, if I were to just do that, I can represent this in this format. Okay, so whereas inside here would be the ratio of the side lengths. So how does that work? Okay, well, really all we're going to do is, so we've got 20 over 36, and so we need to get rid of this squared. How do we get rid of something squared? I'm going to go ahead and apply it on this one. How do we get rid of a square? Well, the opposite of a square is a square root. So I'm just going to take the square root of, let's see if you can see that, big divide by sign. Okay, so that one's easy. Okay, I'm going to go over here. That's 6. So what's the square root of 20? The square root of 20 is, this is the product of 4 and 5, so this is going to be 2 radical 5. Okay, well, 6 is 3 times 2, so this can simplify to final answer radical 5 over 3. Okay, remember this is 6 times 2, the 2's become 1. So, going this way, so this is the ratio of the side lengths. Okay, so answer, yay! Okay, the next one, guide practice number 3. This one's a little more challenging. Anytime you're given a word problem, this is something very subtle, but they did something very, very sneaky to us, and I thought it was kind of cruel. So they gave us inches in the first rectangle and feet in the second rectangle. We're going to deal with the inches at the very end, but right now it's like, okay, so just know that you've got to deal with this fact that this is in inches and this is in feet. Now, sometimes you can front load it. I mean, you can change the inches now to feet or the feet to inches. I'm going to go ahead and do it at the end, but often it's easier to change it earlier. So, changing these to feet now might be easier. It just depends on the situation. So, what I'm going to do is use my rules here, okay? And I know that the perimeter of this one is 66 inches, and the other one, if I've got, let's see, I can find the perimeter, adding up all these sides, so 20 plus 20 plus 35 plus 35. Hold on one second. Okay, pause. I decided to go ahead and deal with inches on the front end, like I said. So, converted 35 feet to 420 inches, 20 feet to 240 inches multiplied by 12, knowing that there's 12 inches to 1 foot. Okay, so perimeter, just simply 240 times 2 plus 420 times 2, or just add them all up. And I got 1,000 20 inches perimeter. Areas is 420 multiplied by this, so we've got a pretty big area going on here. Okay, so the question asks us, they want to know, they ask, what is the ratio of the side lengths, okay, and they also know what is the ratio of the area. Well, ratio of the side lengths, I can take perimeter divided by perimeter, so I've got 66 divided by 1,320. That's why I went, oh, and I paused, because with the ratio, we want the units to cancel, okay, we want them to become 1. And so now the ratio is 1 to 20 for the side lengths. So this is side lengths. All right. Now for area, okay, we've got this, okay, and we know the area of this one. So we've got this, and we know the area of this one. We're going to do the exact same thing in the very first problem. We're going back up here. If you remembered, I had the ratio of the side length. I had the area of one of the triangles, and so I set this up and I squared this area, the side length ratio, and set it up to the areas. Okay, so I'm going to do the same thing down here. I've got the side lengths, so I'm going to go ahead and square those. Okay, 1's a nice number because 1, yeah. And then I've got to make sure the corresponding parts match. So which one's this? This is going to be the small one because, I mean, this is going to be honking huge one. That referred to the denominator here is the big one, the big perimeter, big number. Okay, big number, got to go with big area. So that's the biggest part is just making sure you match the parts. So this one's going to be 100,800 inches squared. Okay, and so now we're looking for x. Okay, so now I simply want to take that number and essentially want to divide by 400. So this times this times this, 220 squared is 400, dividing this out. And so then x is going to be 252 inches squared. Okay, so the area of this one here is 252 inches squared. Okay, I think we have time for possibly one more. So let me pause here and get that one set up. Okay, so I'm going to take a look at number 16. Maybe pause and take a look at number 16 to read it real quick. It asks us about a regular pentagon. These are charged words. Again, you know what this means. Pentagon, 5-sided figure. Regular is an important word. Remember, regular is all sides are congruent and all angles are congruent. Okay, so this is a charged word here. All right, so they told us the side length is 12. Well, if one side length is 12 and it's regular, that means all side lengths are 12. And the area is 248 centimeters. All right, so first thing we wanted, and then they told us, so we have first pentagon is for, I'm looking at the time, I'm going, first pentagon is this, and second is this. I kind of like to leave the information separate so I can make sure I don't cross over. So how do we go about this? Well, we need the perimeter of the first pentagon. How do we do that? Well, it's regular. There's 5 sides. Okay, so 12 times 5, all right, is, let's see, 60. So 60, all right, is the perimeter. I'm going to stack the perimeters now. Okay, I have 60 to 140. All right, and that's going to give me the ratio of the side lengths. The ratio of the side lengths, that reduces down to 3/7. Okay, that simplifies 3/7. Yes. Okay, now we can set up with the area. So now 3/7 squared and squared is going to equal 248 over x. Okay, and so 9 and 49. So then 9 times x times 9, and then 40 equals 49 multiplied by 248, and simplifying that out was what? 1,350 centimeters squared. Let me double check that. My work here, double check. And some change, and I rounded. So, all right, I'm out of time. Looking at the timer. Have a great day. Email, text if you got any questions. All right. Bye bye.